Hello, welcome to my video about algorithms and data structures introduction. The world we live today is fully powered by software. If we're talking about mobile phones, personal computers, or even self-driving cars, everything is powered by software. And what powers software? Well, algorithms and data structures. So algorithms are basically processes, instructions that perform a certain task. So understanding algorithms is fundamental for every software programmer. So let's get ready learning about algorithms. In this course, we'll talk about what are algorithms, then we'll see some basic data structures, then we'll talk about some sorting algorithms and searching algorithms. In order to follow this course, this video, you should have some basic knowledge of programming, for example, how to create variables and functions. Also, you should be able to use a text editor for writing the code with me. I suggest Visual Studio Code. I will also show a link where you can download Visual Studio Code. And yeah, having some basic knowledge of programming language is required. Python or C#. For Python, I have a separate video where I explain how to get started with Python from zero. I will put the link in the video description so that it's easily to follow along. Let's see some links where you can download the necessary programs to follow along. So Visual Studio Code can be downloaded from this link, codevisualstudio.com. Then we'll need also Python in order to execute our algorithms. And yeah, also the source code, the completed source code I posted on GitHub, so I'll put a link where you can download the source files. Before going deeper into algorithms, let's talk about data flow. Data flow basically means that we have some input data. We have an algorithm which performs certain operations on the input and returns an output. For example, sorting an array in ascending order looks like this. So we have the input array. We apply a sorting algorithm, which in the end returns the sorted array. Let's talk about some algorithms characteristics. We will talk about the complexity of algorithms. So for example, the space complexity, this means how much memory does an algorithm require. Also the time complexity, how long does it take for an algorithm to complete. We talked about the inputs and outputs, what does an algorithm accept as an input and what are the results. And the classification of algorithms, serial, parallel algorithms. There are exact algorithms, approximate, deterministic, and non-deterministic. And also algorithms have to be efficient, and we should use the right data structures for the right purpose. We'll see how to choose the best data structures based on the problem we want to solve. Algorithms have to be efficient. We choose proper algorithms and data structures to increase the performance of software. The algorithms have to be scalable to handle large amounts of data and maintainable. So well-designed algorithms and data structures lead to cleaner and more understandable code. Let's see some common algorithms. Nowadays we have this searching algorithm, for example, finding an item in an array. Sorting algorithms, for example, if we take as an input a data set and we want to apply a sort order to it, either ascending or descending. We have also computational algorithms, for example, given a number, calculate another value, or for example, checking if a number is prime or odd. And we have the more advanced graph algorithms, which, for example, solving problems related to graph theory. But we're not going into the detail in this introduction course. We will talk also only about the most basic algorithms. Good. Talking about algorithms, we have to talk also about this, how we can measure the algorithm performance. So how fast is an algorithm? We have the big O notation here. This classifies the performance as the input size grows of data. This O means the order of operation, is the time scale to perform an operation. We have the constant time complexity O1, with, for example, in an array to look for a single element. We have the logarithm. These are basically in ascending order. So this O1 is the fastest time to perform an operation, and we're going down the logarithmic time. For example, if we have a sorted array, we can do a binary search. Then we have the linear time. For example, if the input size grows, so the time will grow proportionally linear. And we have the log linear time. For example, more complex sorting algorithms like merge sort. And we have the quadratic time. For example, this takes very long, so this is the least effective. For example, the bubble sort, where we have two for eaches, and in one for each we do another for each, and this basically means we are traversing the input a lot of times. Working with programming algorithms is very tightly related to working with data structures. Because data structures are a way to store data. We have to select the base data structure to represent the data set. We have the primitive data structures like integer, char, and float. And we have also the non-primitive data structure, which are more complex, and this one are derived from primitive data structure. For example, arrays, linked lists, tags and queues, dictionaries, and more advanced binary trees. Some common operations on data structures. So for example, inserting an element, deleting an element, traversing input data and accessing each element once. Searching, for example, finding an element within a structure, or sorting, for example, arranging elements in a ascending or descending order. The first data structure we're going to talk about is an array. Basically, an array is a collection of elements identified by an index. So for example, this you see here, for example, the first value is index 0 and is the value 42. And for example, having this array, we can access each element by its index. So the index 1 is basically the second element. And we have, of course, the multi-dimensional arrays. This one, we have here rows and columns, and we can access an element by its row index and by its column index. And let's see an exercise in Visual Studio Code about arrays. Let's open up Visual Studio Code, and here we see we have the I have here a list of exercise files from GitHub. The link is in the description, and here we can see the editor, the Visual Studio Code editor. I have installed also some extensions to make it easier to write and debug Python code. If you search for Python, you can find these extensions. They give us helpful clues and tools for writing easier Python code. Let's open up the first file. So I already created here an array variable which holds for elements. So for example, let's see how we can access an element from the array. For example, want to print here the first element, which is basically index 0. Let's run this. we have, in order to run this program, we have to open a new terminal. And here, after we have also installed Python locally, you can write here Python and just write the name of the file, so arrays.py, and run it. You see we get it to printed because it's the first element. We can also write here directly some operations, save it and run it again. You see we get the addition of these two elements. Good. Next, we have another exercise. We can apply what we learned about linear searching to determine if a list is sorted. For this one, we'll use a list, an array. This one will have the linear time complexity because it's not sorted and we want to go over each element. Again, we'll use Visual Studio Code. For this one, let's open up again Visual Studio Code. And we open this. We have the input data, we have two arrays, and we want to determine here which of this one is already sorted. We have a method which is not yet implemented, but we will implement it now. For example, let's write the implementation. So how can we determine if a list is sorted? So we get as input parameter the array, and we want to iterate over it to check if it's sorted. We will use a for e in. We'll go over each element. We go the length the array. Because it's zero index, we have to use it like this. And we'll check if one element is greater than the next one, then this means that the array is not sorted. +1, this means that we want to return false here. Means it's not sorted, but if this was not the case, then we will return here true. Means that no elements was in descending order. Return true. Okay, good. Now I save this and let's run it again. Python. We just have to write the first letters and press tab. It will autocomplete the name. And we'll see that the first element sorted returns true and the second one returns false. Good. So this was the second example. Let's talk about array operations and about the performance. So calculating the item index and getting an element from an array is very fast. So basically it's a O1 complexity because it returns the element and no additional operation is needed. Inserting an element at the beginning is a linear time complexity because if you insert an element at the beginning of an array, then all the next elements have to be shifted in memory, and this is adds to the complexity. So as the input size grows, also the time complexity increases. Or inserting or deleting an item at the end is a fast operation on an array because all other elements stay in place. Next, we're gonna talk about dictionaries. So basically dictionaries are similar to arrays, but here we have a key value pair. So for example, in this we have this key to value mappings where the key is A. For A we have the value 10, for B 20, for C 30. Dictionaries are typically very fast. The keys are unique. For example, this is an example how we have two keys here, and accessing an element by the first key returns the value 1. Good. We have another Python example for value counting with a dictionary. So supposing we have an input list with some colors, which some of them repeat, some of them not. And for this one, we can create a dictionary to represent this data structure in memory easily. So for example, the red color appears 4 times here, the blue one 2 times, and the green appears 1 time. How can we implement this in code? Again, we'll use Visual Studio Code for this. I will open again the file here, and this file will be needed. So I have again this color list, and we want to call this method which gets the input, the color list, and prints the dictionary basically at the end. Let's delete this and start implementing. Again, this will work like this. We define a variable here like this. We have the built-in dictionary in Python, and here we will iterate over all elements in list. So if the item is already in the dictionary, keys, we have also IntelliSense. Then we will increment this dictionary value. Else we initialize this key. We add it basically to dictionary, and we set it to 1 because it's the first time appearance. And yeah, we have to like this, and here we want to return the counter. Good. Let's run this again. Counting dictionary, and it prints here nicely how many times each color appears in the dictionary. Next, we're going to talk about another common data structure. We will talk about linked lists. So basically, linked lists are a collection of data elements which we're calling nodes. Each node contains a reference to the next node, and the elements hold also data. Basically, this is a linked list. So this first element is the head element, is the starting point when doing searching. The value is 38, and we have also in the node a reference to the next element, and the last element has the pointer to null because it isn't followed by any other node. We have, of course, also double linked list. These are similar to linked list, but all elements have also a reference to the previous element, so we can iterate in both directions. So some properties of linked lists. So elements can be easily inserted and removed. We just manipulate the pointer where we want to insert this element. The memory which holds the data doesn't need to be reorganized like for arrays. and we can do constant time random item access like for arrays. So we have to do an iteration over the linked list to find an element, and therefore the lookup item lookup is linear time complexity O(n). Let's see how inserting of an element works in a linked list. We have the linked list as before. The head is the first element. If we want to insert a new element, basically we create here a new node with the value 78, and we set the head element, this one, as the first head element, and we manipulate here the pointer, so this one points to the first element. Removing an element, we have, for example, the same linked list. We have to delete here this reference from this element to the next element. Then we can remove this element from the linked list, and we have created here the pointer from this element to the next element. We're gonna see now an example of linked list with Python. We're gonna insert an element at the beginning. There are multiple implementation. We can insert in the middle, at the end, but for demonstration we will use also this simple example. And we'll also have in the linked list a method for printing all elements from the list. Good. Let's open again Visual Studio, Visual Studio Code, and we'll open out this linked list element. Basically, I created already this node structure, node class with the constructor where we have the data and we have the pointer to the next node. By default, this is none. And we have a linked list where we are using this. We create first of all an empty list, and as we insert element in the list, we see how this behaves. So for example, let's see, we want to insert a new node in the list. We basically create here a new node. Create this class and we pass the data into it. So now we have to check if the list is empty. This means that the head if it's basically empty, we check if this is none. Then this means that we have to update the head. New node. If not, if it's not empty, the list, we will set this new node as the first element. Basically, the next, we will set this next property to the previous head. And we have to do this also. And the new head will be the new node. So this is the insertion. And we also want a method for printing the elements from the linked list to see how this works. So we're starting, for printing, we start at the first element. So let's say we get the first element from the linked list. So basically the head element, and while we're not none, so while we're not at the end of a list, we want to print the console, the data. And we, after printing, we advance to the next element. Next. And in the end, we print that we arrived at the end. Okay, and we predefined here some inserting logic. So for example, insert these elements here, and at the end we call this new print method. Let's save it and run it again. Python linked list. You see, I inserted these elements in the linked list, and because we inserted them at the beginning, we get them in reverse order, the elements here. Good. So this one was an example about linked list. Let's talk further about stacks. A stack basically is a collection of elements that supports two operations, push and pop. So the last item pushed onto the stack is the first one popped off, and yeah, basically the stack is a LIFO data structure. This means that the last item in is the first item out, and the complexity is very good because yeah, we get only the last element with push and pop. Let's see how this works. So we have the first element 1, then we push another one, the 2, then we get another one, and in the end this looks like a real stack. And getting elements is the same. We have this pop method which simply removes the last element. Again, we will see this in practice. We'll open Visual Studio Code again and see a stack example. Let's go to stacks here. And we basically have here predefined some push operations and some pop operations. We can create here. I created also a class named stack. We created also an array to represent internally these elements, and we need to define two methods: one for pushing an element, one from popping, getting an element out of the stack. And let's see how this works. So for example, let's start with the push. Basically, we just have to, we have this variable here, this class variable, which holds all the items. And if we want to push an element, we just have to append here in this item list. We have to call the append method on our array, and this one appends this element. And yeah, similar for the popping, we have to, yeah, first of all, we want to check if it's not empty, the list. Yeah, we want to check if the length of the elements is 0. This means it's empty. So something right here. So if this is not 0, if it's not empty, then we're gonna get one element out. Pop. Else, if it's empty, we want to return none. Good. Let's run this again to clear my screen. And again, stacks. You'll see we get the element in the order as we described as a stack. So in basically in reverse order. Good. We talked about stacks. Now we're gonna talk about queues. Yeah, queues work a little bit different. The queue structure supports also adding and removing element, but it operates in another way. Is the It works like FIFO, so the first element came in as the first element which gets out, like in a real queue. Here is an example. So for example, in queuing one element and queuing the second one, appends it here at the end. And yeah, the third element, and similarly the dequeuing operation works like this. The first element came in as the first element which gets out. Yeah, of course, in a queue, the difference is here we have to get the first element from the array. Let's save it again and see if it works now correctly. You see, now the queue works as expected. So the first element which came in is the first element which gets out. Next, yeah, let's talk about the applicability of stacks or queues. So stacks are very good for expression processing. They are also good for stack trace, for keeping the method execution, also for backtracking, for keeping for example, the browser back stack if you navigate. The queue, on the other hand, are good for order processing and for message queues. Yeah, we also saw the stack and queue examples. And yeah, next we're gonna talk about another important topic. Let's talk about some sorting algorithms. Yeah, so basically all modern languages have built-in sorting, but for demonstration purposes, I will show you how to manually do this sorting to understand how this happens behind the scenes. So we're gonna talk about the bubble sort and yeah, the merge sort and the quick sort are a bit more advanced, but for demonstration, we're gonna see how the bubble sort works. The bubble sort is simple for demonstration purposes and is basically most of the time used for teaching sort algorithms. It has a very bad performance because we have two for loops, one for loop inside the other one, and this means two quadratic time complexity. But other sorting algorithms are basically more effective. Let's see how the bubble sort works. So we have basically a list which we want to sort, and how do we do that? We take the first two elements first and compare them. If one is greater than the other, we want to sort them and reverse them. So basically we put here the 8 before the 23, and this one continues. We do this for all elements until the whole list is sorted. So this process continues until we've examined all items in an array and the largest value has made its way to the top. Basically, that's why this is called bubble sort. Let's see also an example. We'll use again Visual Studio Code for this. Let's open up the template. I already defined here I defined some input data. We have this array which is obviously not sorted in ascending order, and we want to call this method accepting the input array, and we want to return here the sorted elements. Good. How does this work? First of all, we want to declare a variable where we get the length of the array. We want to know how many items are in the array. Then we're gonna traverse through all elements with the first 4. Good. And we have here another for loop which iterates over all following elements. So this will start at 0, -y minus 1. This one will go until the end, and we are checking now if the present element j is bigger than the next element, is greater than the next element, then we're gonna use a temporary variable to swap this value. And we assign now this value to, we swap basically the values here. And now we can assign the temporary variable back. Works like this. Yeah, now we have swapped our elements. Again, run this bubble sort. Let's see, and we see here we get the sorted array nicely. Finally, I'm gonna talk about searching algorithms. For example, searching algorithms are used when finding a value in a given list. We will have 2 examples. One of them in Python for finding an item in an unsorted list is a linear time complexity, because we have to search in all elements. And we have also an example with binary search, which is more effective in a sorted list. We will see examples of both. The first example is with the unordered list search. We have here the linear time complexity, and again we will use Visual Studio Code to show this, to demonstrate it. Here we have the predefined file. We have to implement only this method here. I created a list with elements, and we want to search for this element. Because the list is not sorted, we have to go through all elements until we find the element. We have here this method. Let's see how we can implement it. Basically, we have to go over all elements in the list and check if the item is present. Basically, we have this target also as a parameter, and if it's present in the list, we just return true. Else, return false. So if the element is present, it means that this method will return true. Let's execute it, save it, clear this. Python unordered list search means we have this element here. If it's is not present, we print that it's not present. If we take another example, for example, let's say 23, which is obviously in the list, and execute this again, we see that 23 is present in the list. Good. It was the first example. And next we're gonna talk about binary search. So binary search has a much better performance. This works only when the input array is already sorted. The time complexity is logarithmic because we are doing here a different approach. So assuming we have this array and we want to do a binary search here, how can we do it? We first of all we get the lower index and the upper index. So the first index is 0 and the last one is 7, and we for example, we want to search for value for the 11 value. If we want to check if this is in the list, we get the midpoint, which is index 4, and we have an algorithm which checks if the midpoint is the value. If not, we know that if the value we're searching is bigger than the midpoint, then we apply another iteration, and we ignore basically the first elements from this list because we know that the element we're searching for has to be in the second part of this, and we're just doing this operation until we find the value which we are searching for. So we just split this in half. If we get the midpoint 30, if it's still not the value we're searching, we split it again, then we do another search in this part here until the element is found. It's much more effective. It has a much better time complexity, and yeah, let's see how this works in Visual Studio Code. We open here the binary search. We see here we have a list of elements, and we want to check if the 48 is in the list, and we call this method. So this is already implemented. I want to explain here a bit how this works. So for example, we have this middle point as we saw earlier, and we check if this is the value we're searching for, then we're returning it. If not, if it's less than the target, we adjust the indexes accordingly to see if we want to search in the lower part of or the upper part of the array, and if the target is not found, we just return 1. So let's run this also. And it prints exactly at what index the value is found. So 48 is there. Good. So this was my presentation about algorithms and data structures. So understanding this is crucial for every computer scientist or software engineer. Yeah, I hope you enjoyed along me how to use these algorithms and data structures to solve common programming tasks. Yeah, no matter what programming language you choose to work, understanding how to employ these different algorithms will make your apps more efficient and easier to maintain. Yeah, as next steps, you can play around with different types of algorithms. Yeah, also check some algorithms books. For example, this book was very helpful for me. And yeah, thanks again for watching, and until next time, happy coding.